Okay, so today's lesson is graphing and writing inequalities. We have been doing equations. Equations have an equal sign. Inequalities have inequality signs, such as greater than or less than. Most of what we do when we solve inequalities is the same as what we do when we solve equations. You already have a lot of the skills you're going to need for this unit. We're going to talk first about what the inequalities means. We're going to identify what solutions look like. We're going to learn how to graph them, and we're going to learn how to write them. So today's lesson should be all brand new material. Let's see, today is the 7th. Okay, to identify solutions of an inequality, first of all, we need to know what an inequality is. An inequality is a mathematical sentence that contains greater than, less than. Those are symbols I'm sure you're very familiar with. This is one maybe you have not seen before. This one means greater than or equal to. So something could be greater than or it could be equal to. This one is less than or equal to. If you get confused about how to say what the symbols are, keep in mind that we read from left to right. So if I'm reading from left to right, I get to the bigger part first. So this one I would read as greater than. Greater than. The next one would be less than, because I get to the smaller part first. This one is greater than or equal to. Or equal to. And this one is less than or equal to. And there's one other kind of symbol that we can use. We don't often see this. We're not going to use it very much in this unit, but I want to show you what this looks like. If we have an equal sign with a dash through it, that means not equal to. And again, that's one that we won't really use in this unit, but I wanted you to see that that is another possibility when we're talking about an inequality. Okay, a solution of an inequality is any value that makes the inequality true. So when we have equations, we're looking for one right answer. We get an answer like x equals 5. There's only one possible answer. When we're talking about inequalities, we have multiple answers. We have an infinite number of answers. So if we have x is less than or equal to 2, it asks whether each one of these numbers is a solution of x is greater than or equal to 2. And the way we find that out is just by testing the values. So we start with -3, and we put that in for x. Is this a true sentence? -3 is less than or equal to 2. Just show me, nod your head if you think it's true, shake your head no if you think it's not true. Is this a true statement that -3 is less than or equal to 2? It doesn't have to be less than and equal to. It just has to be less than or equal to. So if it's less than or if it's equal to, it's true. Is it less than? Is -3 less than 2? Yeah, it's not equal to, but it doesn't have to be both. It has to be one or the other. So this one is true. So let's write T for true. Okay, now let's put in 0. 0 is less than or equal to 2. Is that true? Is 0 less than 2? Either nod or show me now. Is 0 less than 2? Yep, so this one's true also. Okay, let's move on. Let's try 2. Is 2 less than or equal to 2? 2 is not less than 2, but it is equal to 2. So that still makes that inequality true. What about 4.5? Is 4.5 less than or equal to 2? Is it either less than 2 or equal to 2? No. So that one would be false. So the solutions to x is less than or equal to -2 are -3, 0, and 2. We can have an infinite number of solutions. Who can give me another number that would be a solution for x is less than or equal to 2? Max?
1.
1. 1 would work. Michael?
1.5.
1.5. Anna?
-7.
-7. Brian?
-53.
Good. And we could keep going all day long and into tomorrow and into infinity, and we'd never run out of potential numbers. Okay. So next one is one for you to try. Which numbers are solutions of this inequality? I'm not going to have you try this completely on your own. I'm just going to call on people to tell me whether they are solutions. Madison, first one is negative 8, a solution of that inequality. It would be false, right? Negative 8 is not a solution because negative 8 is not greater than negative 3. So let's just go ahead and cross that one out. What about negative 2? Let's see if I'm looking on the test. Okay, that's not here. That's not here. Megan, are you available? Is negative 2 greater than or equal to negative 3? True. If we look on the number line, negative 2 is farther right than negative 3, so it is greater than negative 3. Emma, are you available back there? How about 1? Would that make it true? Yep. I'm sorry, actually that says 1.4. Would 1.4 also make it true? Yes. So 1.4 would make that true. Okay, any questions about that? This is the kind of thing that always makes sense to everyone the first time they see it, but then whenever you have it on the test, you're like, wait, what does that mean? So don't forget about this. You'll have some homework that involves this, but don't forget what this is talking about. Okay, graphing inequalities I think is fun. Couple things we need to know. If we have a greater than or a greater than or equal to sign, so if we have any type of greater than, our arrow is going to go to the right. If we have any type of less than, we're going to use an arrow that goes to the left. And that makes sense because as we go to the right, the numbers get bigger or they get greater. So greater than is going to go to the right. If we go to the left, we get to smaller numbers. That stands for less than. The other thing we have to think about are if there's no equal sign, so if we just have plain old less than or greater than, we are going to use an open circle. An open circle means that it does not include the actual point where the circle is. So if I were to tell you that something like, say, I need more than $3, okay? Having $3 would not be enough because I need more than $3. So to graph that, I would use an open circle to show that 3 is not enough, but anything bigger than 3 would be enough. If we have an equal sign included, then we're going to color in the dot. That means we do include the number where the dot is. So if I said to you, I need at least $3, then having $3 would be enough. So a closed circle would show that I'm including the 3. Let's look at the first example that's up here. I have A is less than negative 2. There's no equal sign here. I just have a plain old less than. So I'm going to put an open circle on negative 2. My pen's calibration is a little bit off, so that went a little farther right than I intended. Now it says less than. So less than tells me that I'm going to go to the left. So the graph of A is less than negative 2, looks like that. Okay, for the next one, x is greater than or equal to 3. I do have an equal sign, so anytime I have an equal sign, I'm going to use a closed circle. So I have a closed circle on 3, and it says greater than or equal to. Anytime I have any type of greater than sign, that tells me that my arrow is going to go to the right. Any questions about that? Okay, the next slide, there are 3 examples for you to try. I'm actually going to have 3 of you come up and put these on the board. So go ahead and try those on your papers, and then we'll go over them. Okay, so I'm going to call on 3 of you. If you do not want to come up, since we are recording this, you may pass. Okay, first one, Jake, would you like to come up? He's reluctant, but he's going to do it. Okay, so first, are you going to use an open or closed circle? Okay, you picked open circle, and that should be on negative 4, but the calibration is a little bit off. And then are you going to go right or left? Okay, nice. Reese, would you like to do the next one? Okay, come on up. So C is less than 0. You can use a closed or open circle. And then which way is your arrow? No, not to the right. If it's less than, use this little back arrow right here. Just touch it with the pen. There you go. There you go. So less than goes to the left because this is saying that C has to be less than 0. So any of these values would be a solution to that inequality. I could pick -4 and that would be true. -4 is less than 0, right? I could pick -10 and that would make this true. But if I picked any of the values where there's no graph, say I picked 2. 2 is not less than 0. So this is showing us the range of values that would make the solution true. Okay, number 3, I'm going to ask for volunteer on because this one is not what it seems. Bryant, come on up and give that a try. Okay, so you weren't quite sure what to do with the M being on the other side, so he actually drew an N in there. And then you're showing closed circle on 3, which I agree with. Then you're showing your arrow like going and stopping at the. So is what you're actually saying is that it's all these values going this way?
I'm saying that the 3 is less than the N.
Okay, good. That's true. The 3 is less than the N. So he did think about this correctly, that 3 is less than or equal to N, but the arrow should actually go in this direction, Brian, because any of those numbers, 3 would be less than, okay? We can rewrite, when you have 3 is less than or equal to N, we could say that this also says N is greater than or equal to 3, okay? Because the N is on the greater than side, right? N is greater than or equal to, so we can actually write it that way. N is greater than or equal to 3. So the graph would look like this. We actually don't need to include the letter N. We would have our closed circle on 3. 3 is less than or equal to N. So here's N. The part that we draw is representing the N. N itself has to be greater than or equal to 3. If we pick 7, we could put 7 in here. 3 is less than or equal to 7. That's true, right? If we put in a 10, 3 is less than or equal to 10. That's also true. But if our arrow goes the other way, let's pick a point like 0. 3 is not less than or equal to 0. So the points going to the left would make that inequality not true instead of true. Okay, let's talk now about writing inequalities. So this is just taking what we did and going backwards. So we're starting with a graph. We're going to write the inequality that goes with this graph. So for the first one, I have a closed circle on -3, and my arrow is going to the right. So if it's going to the right, I need to have greater than. If the circle is closed, I need to add the equals. So I'm going to say that N has to be greater than or equal to -3. I could also write this as -3 is less than or equal to N. In this case, I'm saying that this -3 is less than or equal to all of these N values. Okay, let's take a look at the next one. Michael, how do you think I would write an inequality for the next graph?
N is less than, N is greater than -5.
Good. N is greater than -5. Volunteer to tell me what other way could I write it? Brian?
-5 is greater than N.
No, I need to go the opposite way. I need to say -5 is.
Oh, I said it wrong.
Okay, you wrote it right. Said it wrong. -5 is less than N. Is the other way I could say that. Taylor, how would I write the last one?
2 is less than N.
No, well, first of all, we have a closed circle. So we're going to want an equal sign in there. 2, here's 2. The rest of the graph is the n. How does n compare to 2? Is it less than the 2 or is it greater than the 2? It's less than, so we want to say that the n is less than or equal to 2. So then what's true about 2? 2 is what compared to n? Anyone tell me the other way? Megan?
Greater than or equal to n.
Good. I can also say that 2 is greater than or equal to n. Okay, any questions about this? Okay, next 3 are examples for you to try. Okay, the first one, Avery, what did I write? Good. N is greater than negative 8. Anna, what's the other way I can write that?
Negative 8 is less than or equal to n.
Not equals because it's an open circle.
Oh, yeah.
Just
Yeah.
less than. Okay. Morgan, how would I write this
Caitlin
one?
Ware, please report to the guidance office. Caitlin Ware, to the guidance office.
5 is less than n.
Okay, so if you're saying 5 is less than n, you're saying that this number 5 is less than all of this. Is that true?
No, n is greater than, or n is less than 5.
Okay, so we could say n is less than 5, or we could say that the 5.
Boys in the office.
is greater
Boys
than.
in the office.
Okay, Trey, last one. How could I write that one?
Greater than -6.
Not just greater than, we have a closed circle,
Oh, greater than
or equal to negative 6. Anytime the circle is closed, we have to have that equal sign. How else could I write that, Max?
Negative 6 is less than or equal to n.
Good, we're saying that this negative 6 is less than or equal to all the rest of the graph. Okay, questions about this? David? Yes. Okay, last thing is writing inequalities to model each situation. These kinds of things, people tend to get a little bit twisted up with. You have to really think about what each one means. If I tell you this room can seat at most 25 people, before I decide what inequality, I'm going to test some points. I'm going to test something less than 25. What about if I said to you, let's see, Bella, could I put 20 people in this room if it can seat at most 25?
yes.
Yes. Could I put 25 people in here?
Yes.
Could I put 27 people in here?
No.
No. So it can't be greater than 25 because none of those numbers work. So I need to say that I'll use R for room. R has to be less than or equal to 25. Okay, what about the next one? I'm going to have one of you give me what you think and then we'll test it. You need at least $100 to open a checking account. Volunteer to tell me what inequality you think you would write for that. Michael?
N is greater than or equal to 100.
Okay, let's test that. So let's use a number that's actually greater than 100. Could you open a checking account if you had $150, Michael?
Yeah.
Could you open it if you had exactly 100?
Yes.
Could you open it if you had $80?
No.
No, so you did make the right choice there. Okay, Brian, try the next one.
R is greater than 5,000.
Good, and let's test that. It says you need more than 5,000, so could you buy a car if you had 6,000?
Yes.
Could you buy a car if you had exactly 5,000?
No.
No, because it says you need more than that. Could you buy a car if you had 4,000?
No.
No. Okay, so you made the right choice. Madison, how about the next one?
N is less than 20.
Okay, and let's check that to see if that works. So let's pick a number that's less than 20. Could the glass hold 10 ounces of water? Could it hold exactly 20 ounces? No, it's probably like one of those, you know how sometimes you can fill them and it's like almost over the top. Could it hold 30 ounces of water? Okay, good, so you made the right choice there also. Okay, we have about 9 minutes left. I want you guys to do this exit ticket, and then this is your assignment. It's out of your textbook, which we've not used in a little while.